Hi, and welcome to MSc. In this video, we're going to be looking at set builder notation. So what is set builder notation? Well, set builder notation is a mathematical notation that allows us to describe a set of numbers, telling us what type of number it is and any type of restrictions to fully describe the set. So here we have an example of a set builder notation that tells us the set it belongs to as well as restrictions. But what would this be like if we actually were to translate this into English? It would look something like this, where we say that a set of x such that x is an element of the real numbers where x is greater than or equal to 2. So that's a lot, but let's break it down piece by piece. The first part here is the set brackets, which are the curly brackets, and that tells us that we're dealing with a set of x. All right, that vertical bar here tells us such that. It tells us that we're going to start to define x more carefully. Then we say that x, and this symbol there is an element of, sometimes called a member of. An element of, and then it says the real numbers. And that's what that fancy R is, telling us that it belongs to the real numbers. So this could be written as a member or as part of or as an element of, and then this is where you'd put your number set. So it could be integers or natural numbers or real numbers. Then we have a comma, and that comma is the where. This is where we're going to start to now break down in smaller or more specific detail the restrictions. And then we say here we have restrictions where x is greater than or equal to 2. So that's the breakdown of what the different parts of the set builder notation mean. Now, set builder notation doesn't always have to have restrictions. Here we've just defined it as x such, or the set of x, such that x is an element of the real numbers. And if we were to sketch this out on a number line, this would just look like this. It would just say, okay, well, this number, this set of x, can be any number we want on a number line. There's no limitations to it at all. And this would be my x variable, right? It can be anything in the real numbers. So we don't always have to have that limitation piece. And when we don't have a limitation, we just close our set brackets and we're done. If, however, we go back to that first example that we just looked at, that said the set of x such that x is an element of the real numbers where x is greater than or equal to 2, if I was to draw that out here, we know that x can be anything larger than 2. So we'll start at 2, and we'll have an arrow indicating that it goes on. And there's no upper limit, it's just a lower limit. But because it includes the 2, you'll put a filled in circle. And that indicates that it's equal to. If, however, we had the same line, but instead of a closed circle at 2, we had an open circle at 2, then what we'd have is we'd have a different set. And we would say that we have a set of x such that x is an element of the real numbers where x is greater than or 2. Not greater than or equal to, just greater than, does not include the number 2. It doesn't have to be, as I said originally, real number sets. It could be other pieces or other types of number sets rather. So here we have just these filled in circles indicating that we have values at -5, -4, all the way up to 5. We're going to make an assumption here for a moment that this is just going to continue on. This pattern will continue in both directions. And if that assumption is true, then what we can say is, well, we have a set of x such that x is an element of the integers. And there's no restrictions on that if we assume that this goes on in either direction. If, however, we had a situation like this, where we only have these values, -2, -1, 0, 1, 2, and 3 will end there. And this we're not going to continue on. It's only those values that are possible. Well, what I know here with the -2 is I know x always has to be greater than -2. And in fact, it always has to be greater than or equal to -2, right? Because it's allowed to be -2. And at the other end, I know that x always has to be less than or equal to 3. So we can incorporate these two restrictions into the description of this set using set builder notation. So we'd say the set of x such that x is an element of the integers, and we're going to have restrictions here where we're going to say where, and we're going to put x in the middle, and we're going to put the lower bound, and we'll put the upper bound. And then we'll say, well, x here has to be greater than or equal to the -2, and it has to be less than or equal to 3. And that defines this set of integers using set builder notation. Set builder notation can then be used to describe the domain and range of functions, and we will deal with that in the future. Thank you so much for listening. Hopefully you found this video helpful.